Look up at the sky. It's something we all do, whether in wonder, curiosity, or simply out of habit. The vast expanse above us has inspired dreams and ambitions for generations. During the day, you see our star, the sun, a nuclear furnace 93 million miles away, burning with unimaginable power. Its energy is the source of life on Earth, fueling everything from the smallest plant to the largest city. Every single second, it bathes Earth in more energy than humanity uses in an entire year. The scale is almost impossible to comprehend, an endless cascade of light and heat pouring across the solar system. For all of history, we've relied on the sunlight that happens to reach us, content with leftovers. We build our lives around the day and night, always limited by what the clouds and atmosphere allow through. But what if we could go to the source? What if we could build a power station in space, where the sun never sets, and capture its energy directly, without interruption? This is the dream of space-based solar power, a vision that could transform our world. Imagine a future where energy is clean, abundant, and as constant as starlight. No more blackouts, no more shortages, just a steady flow of power, day and night, for everyone. This isn't science fiction. Right now, Japanese scientists and engineers are working to collect solar energy in orbit and beam it wirelessly to Earth. Their research is pushing the boundaries of what's possible, turning dreams into plans. The idea, once a fantasy, is now on the brink of reality. With each new experiment and satellite launch, we move closer to making this vision come true. The concept is simple yet ambitious. Satellites with vast solar arrays soak up sunlight 24/7, high above clouds, storms, and weather. They operate in the endless daylight of space, never missing a moment of the sun's power. These satellites convert the captured energy into microwaves and beam it safely to a receiving station on the ground, where it's transformed back into electricity for our use. It's like creating a private sun, directing energy wherever it's needed most, lighting up cities, powering industries, and reaching places the grid can't. This could fundamentally change civilization, clean, limitless power for homes, hospitals, and industries. Imagine the possibilities if energy was no longer a constraint. Our current energy methods come at a cost to the planet. Fossil fuels pollute our air and water, and their supply is finite. By tapping the sun's energy from space, we could solve the energy crisis, fight climate change, and power even the remotest corners of the world. No village too distant, no city too large. We stand at the threshold of a new era, one powered by the cosmos itself. The dream of limitless power is within our reach, waiting for us to take the next bold step. How do you build a power plant in the sky? Start with a colossal satellite, kilometers wide, covered in solar panels. It's launched into geostationary orbit, 36,000 kilometers above Earth, appearing motionless over one spot. The panels capture sunlight and convert it into electricity. Instead of storing it in batteries, the electricity powers a device that turns it into microwaves. These microwaves are focused into a precise beam aimed at a ground station called a rectenna. The rectenna captures the microwaves and converts them back into usable electricity. This system operates continuously. Unlike ground-based solar, it isn't affected by night or weather. In geostationary orbit, the satellite is in sunlight over 99% of the time. It generates a steady, predictable flow of clean energy, day and night. This could provide baseload power, something only fossil fuel and nuclear plants do now, but without pollution. Space-based solar power could redefine how we power our world. Why is Japan so invested in this cosmic endeavor? Geography and history. Japan has few natural resources and relies heavily on imported fossil fuels, making it vulnerable to global shocks. The 2011 earthquake and Fukushima disaster exposed the risks of nuclear power and deepened Japan's energy crisis. Shutting down reactors forced even greater dependence on costly, polluting imports. Space-based solar power offers a path to true energy independence, clean, safe, and domestically controlled. It aligns with Japan's commitment to carbon neutrality and environmental protection. This project reflects Japan's spirit of innovation, pushing the boundaries of science and technology. For Japan, it's not just about energy, it's about pioneering a new future for humanity. Before we can build giant power stations in space that could one day power entire cities, we must first take small, careful steps. Every great leap in technology begins with a single, crucial experiment. Professor Naoki Shinohara's dedicated team at Kyoto University is preparing for a groundbreaking test. Their mission, to launch a small satellite, roughly the size of a microwave oven, that will attempt something never done before, beaming usable energy from orbit down to the surface of the Earth. Once launched into low Earth orbit, this compact satellite will generate a few precious watts of power using its solar panels, convert that energy into microwaves, and then carefully aim the beam at a receiver on the ground far below. On the ground, a network of highly sensitive antennas will be waiting, tracking the satellite's path and trying to catch the faint microwave signal as it passes overhead, a true test of precision and coordination. The goal here isn't to power a city or even a neighborhood, but to prove that the principle of wireless power transmission from space actually works in the real world, a vital first step. This test, which could happen as early as 2025, marks a pivotal moment. Years of research, planning, and innovation all coming together in a single, real-world demonstration that could change the future of energy. Scientists have already managed to beam power over short distances here on Earth, but sending energy from space to ground is a completely new challenge, with unique obstacles to overcome. If this experiment succeeds, it will be a historic breakthrough, the very first spark on the long path toward practical space-based solar power, opening doors to possibilities we've only imagined. This is the proof of concept that could ignite a new era of clean, limitless energy from space, transforming how we power our world for generations to come. Beaming energy from space down to Earth is a feat of incredible precision and technological mastery. Imagine trying to hit a coin in New York with a laser pointer all the way from Los Angeles. That's the level of accuracy required. The satellite's transmission system must be aimed with pinpoint accuracy, constantly adjusting to stay locked on target as both the satellite and Earth move. The microwave beam must remain stable and focused as it travels through the ever-changing layers of our atmosphere. Even the slightest miscalculation could cause the beam to miss the Rectenna field entirely, wasting precious energy. Fortunately, microwaves can pass through clouds with very little interference, making energy delivery reliable even during storms, heavy rain, or cloudy days. Of course, some energy is lost to water vapor and rain in the atmosphere, but engineers carefully monitor and compensate for these losses to ensure a steady, dependable flow of power. The Rectenna, a vast field of simple, specialized antennas, captures the incoming microwave beam and efficiently converts it back into usable electricity. Its large size keeps the power density low, ensuring safety for people, wildlife, and the environment. The captured electricity is then processed and converted into the standard alternating current used by our power grids. From there, it's seamlessly fed into the national grid, ready to power homes, hospitals, schools, and electric vehicles across the country. The journey, sunlight, captured in space, transformed into energy, and beamed down to Earth, lighting up our world, one city and one home at a time. Space-based solar power could soon make this extraordinary process a routine part of our daily lives, powering a brighter, cleaner future for everyone. Is it safe to beam energy from space? Absolutely. The beam is spread wide, so its intensity is low, similar to standing near a cell tower. It's well within international safety limits. Multiple safety features are built in. The Rectenna sends a pilot signal to the satellite. And descendensand omendidi en vi albi dur indrag. The beam shuts off instantly. Space debris is a challenge. These huge satellites are big targets, so they must be robust and maneuverable. And maintenance is another hurdle. Sending astronauts is costly and risky, so future systems will rely on advanced robotics for assembly and repair. Autonomous robots will inspect, maintain, and fix components, ensuring decades of smooth operation. This project pushes the boundaries of energy, robotics, and artificial intelligence. Safety and reliability are at the heart of the design. The biggest obstacle is cost. Building and launching massive satellites is expensive. Billions for research, manufacturing, and especially launches. Every kilogram sent to space costs thousands of dollars, and a single satellite could require hundreds of launches. For space-based solar power to be viable, launch costs must drop dramatically. That's why reusable rockets are so important to this vision. But think of the cost as a long-term investment. Once built, the satellite's fuel, sunlight, is free. Over decades, it could generate vast amounts of electricity. The key is whether the value of clean energy outweighs the initial expense. Early electricity will be costly, but as technology improves and mass production ramps up, prices will fall. One day, a sunbeam from space could be cheaper than fossil fuels. Space-based solar power could be a game-changer in disaster relief. When disasters strike and grids fail, a portable rectenna could be quickly deployed to the crisis zone. A satellite could redirect its beam, delivering life-saving electricity within hours, independent of damaged infrastructure. This power could run emergency shelters, water purification, and medical equipment, enabling rescue teams to save lives. It's an electrical lifeline for communities cut off from the world. The same technology could bring power to remote islands, mountain villages, or polar research stations, places where traditional grids can't reach. All that's needed is a rectenna, bringing electricity for education, healthcare, and development. Space-based solar power could help bridge the global energy divide. Beaming solar power from space is more than engineering. It's a choice about our future. We can stay tethered to finite resources, or harness the sun's boundless energy in a way once unimaginable. Japan's project could spark a new energy revolution, powering a global grid with clean electricity. This could drastically cut fossil fuel use and greenhouse emissions, helping preserve Earth's ecosystems. Abundant energy could also fuel space exploration, powering moon bases, Mars missions, and asteroid mining. The dream of a spacefaring civilization becomes real with limitless power. We have the science, technology, and vision to build a power station in the sky. The path will be challenging, but the reward is clean, abundant energy for all. A future powered by starlight, not by what we burn. Japan's bold step is the first flicker of light that could one day illuminate the world.